Welcome to Adventures with Yufeng, where we explore new and interesting concepts, tools, and ideas, usually live. My name is Yufeng Guo, and I'm excited to be joined today by Sara Robinson, a Google Cloud developer advocate who focuses on machine learning for data scientists. She's been focusing in on explainability lately, and I'm really excited to have her join me today. How are you doing today, Sarah?
Doing good. Great to be here.
Yeah, and we're kind of joining here today in separate places, thanks to uh, social distancing. Oh, my Google Home is making noises. Um, and so, yeah, today, I asked you to come join me and talk a little bit about explainability. So I'm really excited to kind of dive into that and, talk a little bit about why explainability matters in machine learning and data science and so on.
Yeah, for sure. Looking forward to it.
So I guess to start us out, you had sent me a link to a TensorFlow tutorial, yes, and we're
Yes.
specifically looking at what is an interesting aspect of um, explainability in terms of relating it to time series data. It's certainly not a common, um, you know, type of data for folks to be doing explainability on, at least not yet.
Right. A lot of the explainability work that I've seen right now is on, image models or regular tabular models to say, let's say you're predicting like the duration of a taxi trip and you want to know like why the model predicted a certain trip duration. Maybe it had to do with like the time of day or the place that you got picked
Mm-hmm.
up. Um, I've seen less work around or research on explainability for time series
Mm-hmm.
models. So it's something that I've only just started to explore. So kind of living on the edge here, thought it would be a fun topic to check out.
Definitely, and I'm looking forward to seeing what we encounter along the way. So let's head on over to the code here, and I've got this the time series forecasting tutorial open on the TensorFlow documentation page. If you're following along,
Yep.
those folks online, that's going to be this link right here, tensorflow.org/tutorials, structured data time series. Um,
Yeah, so this tutorial just will train a few models locally. There's no cloud aspect of inside this tutorial specifically, so that's the part that we're going to be adding.
Great.
So we'll start with the code here. So you can go ahead and click on that running Colab
Yeah.
button.
So
And I think
yeah, I got it
you've
set
got it
up in
set
the
up.
next tab, but for those following along, you can click that button. It'll pop up over here. I've saved it to Google Drive, just to have my own copy, and then we can kind of persist that state. And just for sake of space, I'll also pop this up and give us a little more room to work with.
Cool. So we'll start running the
Mm-hmm.
notebook. What we'll actually want to do is so explainability on AI platform supports TensorFlow
Oh, right.
1.x.
And Colab just moved
Um,
their defaults a little while
yes,
ago.
they just moved
Oh,
it
that's
to
what I get
2.
for running that cell
So
first.
yeah, sorry, you're gonna have to restart the
Yeah,
runtime.
it's a
If you
good
want to add
demonstration.
that magic
Uh-huh.
in, where the Colab magic thing that's
So
like
we're going to need to
import
restart the
TensorFlow
runtime.
1.
And there's a difference between restart and run all and restart runtime, right? Because
Yes,
one is,
exactly. We don't want to run the cells
yeah,
just yet.
especially since we need to change it.
Um, Yeah, if you need help finding that version magic, I can look for it. Unless that's in the
Well, if it's
snippets.
not, maybe it should get added. Here we go. We got various upgrades, but there certainly is no
Um, let's see.
Colab TensorFlow magic. Here we are. Looks like this is the one we're looking for here. Does that look right
Yes,
to you?
exactly.
And
Yep, that looks
we'll
right.
paste that back. Nothing like some good old copy paste. And I
Exactly.
think we want,
TensorFlow 2 is something that the team is working on, but for now, we will work with TensorFlow 1.
so we're going to set the 1x. We're going to print the version as we do the import right here. So
Yeah, good call, just to make sure it's
always,
imported
yeah.
correctly.
TensorFlow is not defined. Oh, that's good.
Oh, yes,
All
TF-dev
right.
version. There we go. We're good to go. Okay, so this collab, I've run through it a couple times. It uses a weather data
Mm-hmm.
set. Um, it's got it's a pretty big data set, and the time series aspect here is predicting the temperature at a future date
Gotcha.
based on a window of data that you specify the length for. So the model that I want to deploy is actually in the second part of the notebook, but I think you'll need to run all the cells up until
Okay.
that point, just to do the data pre-processing
Yeah, and if
correctly.
nothing else, I need to download this file, which is going to do wonders for our stream.
Yeah.
Uh,
Oh, yikes. I didn't think about
no, it's all
that.
good. I think it finished actually. Nice thing about collab, we
Yeah,
can
it's
we can
pretty.
see it. Well, either that or hasn't started. Those are the possibilities. Like I would have thought it was going to be here.
Oh, yeah. I don't know if that updates unless you use the UI to upload.
I mean, if I hit refresh, it usually
Let's see.
does something.
Let's see. Well, you could try running the read CSV to see if we can preview
Oh
the
yeah, that's
data.
true. I was just going to ls, but that's even easier. Oh, it seemed to work.
All right. It looks like we've got it, even if
Yeah,
it's not
I
showing up in
wonder
the
where
UI.
it must not have saved it to the path that, like, wherever the zip path was. Let's, um,
Oh, that
right.
could be a different path than what's
Yeah,
showing in the
it's
UI.
under root Keras datasets. So,
That feature in Colab is pretty cool. I only recently discovered it. Instead of having to like programmatically copy
oh,
files,
this
you can
file
just
editor,
upload
yeah,
right there.
exactly. Especially if you have it locally.
Yeah.
Root Keras, where is this? Oh, yeah, root. Huh.
Hmm. Okay.
I don't know where it
It's
is.
a
It's
mystery.
somewhere. Now I don't know what folder I used to be in, which is always fun. Anyways,
I don't know if there's a way to navigate
yeah, I
back.
just leave.
It's all good. It's somewhere
Yep,
here.
it's definitely somewhere,
We have
and
the
we have a
data.
path to get to it. Uh,
So that's just a nice preview of what the data looks like. We're not going to be using all those features. Um,
Interesting.
okay.
So we have time, pressure, temperature. This is a real test of how well we know our units. Temperature. Well, I don't know
Yeah,
what
I definitely don't know all
teapot
these.
in Kelvin. Uh, Not sure what that is. There's some pretty big numbers. Oh,
Dew point,
yeah, that looks
maybe?
like dew point in degrees centigrade. It's great that they're using consistent units. RH percentage, not a clue. VP max, vapor pressure, something like that. Act def. Oh man,
Could
if
be.
there were any weather geniuses on here, please help us out. Over on the live chat, there's you can put some words. I'll put something in here now. This is a live chat. That should be
I'm
either
also
to the
on there,
right or down
so
below the
yep,
video. Folks
I
should be
see
able to
it.
see that and type into it. So we'd love to have you on. Let's see. SH, no clue. H2OC, millimoles per mole. We have a rho constant. A lot of values here. And so you were saying this is weather data, climate data for a specific location?
Yeah, I'm not sure about the exact location of it, but um, it's over quite a bit of time. Maybe there's some more
Yeah, there's
details
some
on it
text
in the
down
notebook.
here that looks interesting. Um, every single hour,
So we have an observation every 10
so 6
minutes.
observations per hour, 104.
Oh, you could just print just length of data to see how many rows we're
Oh yeah,
working
that'd be
with.
useful.
Actually, not sure.
So looks like we have 420,000, just over 420.5K
Okay,
rows.
so
Interesting ranges. Like these
yeah,
values going
especially
down to
for
negative
temperature.
10,000, but we don't know what they mean, so that's no help. But they look
Yeah.
like outliers, is what I mean. That must be like a placeholder for like a null.
Yeah, probably.
Given a specific time, we want to predict temperature 6 hours in the future. 6 hours in the future. That's substantial. Okay. Um,
Yeah, so for time series, you can choose like different windows of how many past data points you want to train it on. You can run the cells as we talk
Okay.
about this. Um, so we're actually going to use the second model. The first model, what it does is, I believe it only uses temperature as a
Mm-hmm.
feature, and time, obviously, to predict the temperature at some point in the future. Um, that one might not work with
V1.
TF1, but it's okay. Everything else should still run, I think.
I forget where TensorFlow's
Uh,
set seed is in V1.
yeah.
Huh. Oh, you could call it from V2
Oh.
compat, but that seems to be a weird
Oh.
workaround.
Yeah. We can. I think we can just
All
skip
right.
that.
We don't need to have it be exactly the same as what they. Oh, it worked. Wow. Yeah. So you
Oh,
just prepend it
nice.
in, and then
Okay.
it's like you access the V2 API, but it's like backported, I guess. Nice.
So yeah, you can see what they're doing here. Part one. We can run through
Okay.
part one. And so it's just using
Temperatures.
time and temperature.
It's a pretty cold time of year here. -8 Celsius.
Yeah.
Oh, this is cool.
So you can see some
Okay. This is
trends of
over
the
a couple of
data.
years. This is quite a wide, 2009 to 2016.
Yeah.
And we got some cold years in the
So
middle
we
here.
can
It
see
really
some
drops. Mm-hmm.
seasonality. Then it looks like the notebook is going to normalize the data, which is always a good thing to do.
Yep. Oh yeah, I see that. And then so that's what they mean by univariate. We're only doing temperature and none of the other stuff.
Hmm.
The model will be given the last
Yeah.
20 recorded temperature observations. Okay, so it's going from the previous 20, and we said there were 6 per hour. So that's like a little more than 3 hours of data.
Right. So it looks like, measures 1 through 20 to see if we can predict the temperature at time step
Yeah.
21 is the goal.
So this sets up our univariate data and does all our splitting for us. So that was a handy function from earlier. I wish we should look at it
Yeah.
a little bit more maybe. Dataset start
Yeah, I really
when
like this notebook.
it's very cleanly done.
Hmm. Props to whoever wrote it. So this one trains just on the temperature feature, as I mentioned. The reason we're not going to deploy this one is that the second model in this notebook uses a couple more features, which makes things a little bit more
Cool.
interesting. But still useful to train the first model and see what it looks
Yeah.
like.
So this is the
So that
20
shows
values,
all of our training. Yeah, our training
and this
window.
is the one that's 6 hours later, theoretically.
Yep. So that's what it should
Huh.
predict for the first data point in our training data set.
So earlier in this, was that like a customized? How did it do the offsets? You know what I mean? Like if the y value that maps to a given x is the value that's, what did we say? The next. Oh, it's just the one next time step.
I think it's one
Okay, so it's
next
not
time
like
step. Yeah.
it's 6 minutes later, not 6 hours later. Gotcha.
Um, and yeah, just to introduce some explainability stuff here when we get to that. So basically, explainability can tell you, how different features in your model impacted the prediction. So when we think of features for a time series model, it's a little bit different. So essentially, explainability will treat those all as different features. That entire window, like each measure
Oh,
from that
okay.
window will be a
So
different
each
feature.
slice of time is its own. Oh, right.
Yeah,
Because in like a tabular form, quote unquote, it would be represented as separate columns, 20 different columns.
right. Yeah, so as a tabular model, this would just be like, an array of 20 different input
Mm-hmm.
features. Um, so we'll be getting attribution values, or that's the goal for this
Yeah.
session. Get some attribution values to see, how much each one
I really
affected. So
appreciate
I
the
think this
plotting here. This
one,
is great.
yeah, these plots are pretty awesome. I think the first one is just, oh yeah, that's just showing you like what the model should be predicting. That X, that's what we're predicting.
We got a simple
for the first model at
baseline.
least.
Given an input point, the baseline method looks at all the history and predicts the next point to be the average of the last 20. Yeah, that's a pretty reasonable baseline. I buy that. So they defined baseline as just mean. Okay. And then it runs based on that.
So, no, it did not great, but
the last 20 data points is quite a bit to be looking back given all the swings.
Yeah.
So we're going to upgrade from running np.mean to RNN. It's pretty huge.
Pretty big upgrade.
It's like going from like some old like 2-decade-old car to getting like a brand new like sports car. Let's see. This is a little background on RNNs.
Yes, so we'll be using an LSTM here. Not quite yet. I think the first one sets up the data set. It's using TF Data API to do that.
We have another.
Just a way to create input pipelines.
We have another handy diagram here.
Yes.
So, do you want to talk through this a little bit for the viewers out there?
Yeah, so here essentially this is showing us like how we're feeding the data into our model. Features in this case is just the temperature value. We only have one feature in this model. And the time steps kind of refers to the ordering of the data. The batch size is how much data we feed to our model at once for one iteration of model updating its weights.
Gotcha. So in our version, since we only have one feature, would it just be this one vertical column not going out this way since it's just the one feature?
Yeah, so I think the original data set had like 14
it had
features. So yeah, this is just the one temperature. And in the next step we'll have 3.
And so each batch, since it had all those time steps with the like 20 seconds, is each one of these little cake slices 1 second? Not 1 second, one time moment or whatever?
I think each one of those is a window.
Okay, so there's 20 containing each.
Whatever we've chosen. Yeah.
Nice.
Which is 20 measurements, or that's what we've chosen.
Yeah. And
can experiment with different values here for window size, but we'll just keep it simple to what they
have here. Yeah.
What they used.
And it's nice that they've taken these common architectures and just turned them into APIs that can be called directly.
Yeah, this is one of the pretty amazing things about Keras. If you haven't used tf.keras, it just makes it really easy to build your model as a stack of layers. That's what the Sequential Model API lets you do. So you can create, an LSTM, which is a very complex type of model architecture, in just this one line of code.
Do you know what the -2 here is referring to by any chance?
I don't. Input shape.
I'm curious what this shape is in the first place. Might throw that in there just.
Yeah, I think input shape. Well, yeah, let's just log what that is. Input shape should be 20. Oh,
yeah,
okay.
It is 20. You're right, but they're doing it with. They're selecting it from the back rather than from the front.
Right. Oh, I see. Okay, that's interesting.
They're doing 20,1. Which is an interesting way to do it, I agree. Rather than doing it from saying the second value. It's the same output, right? But I think it's perhaps in the event that there are more values in the front, they want the last 2.
Yeah, I typically would just get the length of the first value. Interesting. So we can compile that and...
Oh, it's yelling at me.
I guess before... Oh. What's it complaining about here?
It wants you.
Oh, this is another V1, V2 compat.
Well, this is an interesting thing here, right? Because V2 has eager execution enabled by default.
Right, and you can enable it in V1. You just have to
do it manually.
Compat. I don't think we need it for this.
Oh, okay. We can just skip over this.
Let's try to. Try skipping this. I think I've run into this issue before in a different
notebook. Do we need
to
run this too? Should we fit the model?
We don't need to run that since we're not going
All
to train
right,
this
let's
model.
move on then. We won't train, we won't predict. I'll just close this guy up. Part 2.
But you get the idea. Yes. Part 2. We made it to part 2.
The fun stuff.
Yeah, so I thought it'd be a little more interesting to deploy this one since we have a few more features we're working with. I think the P is pressure.
Yeah, millibars.
Temperature, and then I think the last one is humidity.
Okay. Grams per cubic meter.
Air density,
okay.
I think.
That sounds good to me.
Not a weather expert.
I'll take it.
Let's say air density. So now we'll create, our data frame for training this new model, which is going to have 3 features. Yep. And like it says up in the text, if you wanted to add more, just add them to that features considered list.
You just got to make sure you get the very exact text pulled out from the data frame columns in the list, right? So like,
exactly.
It's just df or big.
That columns should give you. So you want to use those exact string values. Be careful how you do that. Don't miss a space. Yeah. Okay, so then we'll visualize those features and how they, in the next cell, see how they change over time.
Wow.
Yeah, the subplots thing is a cool feature. So yeah, here we can see pressure is the first blue one. Temperature that's what we visualized before. And then what we think is air density is the last one.
It's very interesting that at a glance, the air density seems to be like inversely correlated to temperature.
Inverse, yeah. Yeah, I just noticed that too. Not sure if there's a pattern on the pressure.
Yeah, it's kind of all over the place. And then we have that one, what I would guess is an anomaly just because it's so low.
Yeah.
We don't see any craziness on the, well, actually there's I
actually don't see that reflected in the temperature.
But you do see it in row.
But I do see it. Yeah.
Very curious. Okay, so it's not a perfect mirroring. So there can still be signal in here yet.
It looks like we're going to do some normalization again.
Probably in a real one, we'd probably, to productionize and all that, you'd probably write that up into a function so we wouldn't have to manually write the implementation twice.
And AI Platform actually does let you deploy custom functions to do that. So let's say you wanted to handle all of that on the server.
Yeah.
We could do that. Probably outside the scope of this.
Next time.
Multivariate
data. Okay, so this is the multivariate version of the univariate data function that we had earlier. And it does some more.
Yes, so we're taking, this time, 720 observations, which represents 5 days of data. And then let's see what we're predicting. We're predicting the temperature 12 hours in the future.
Wow. It's another big jump. So 12 hours in the future.
Yeah.
This again is So we're not going to predict one time step forward like we did before. We're jumping 12 time steps into the future since it's 1 every hour.
Right. And then it looks like in that last sentence, they talk about how they calculate that. The temperature after 72 observations. So that's kind of a bold move. We'll see how the model does.
And that.
And then. Oh, go ahead.
So I'm just looking at this 72, right? That, like you mentioned. I'm seeing that future target is this value. It's the third from the end argument in this multivariate data. I'm really curious how they wrote this up. So that's this target size variable, which is kind of what I was eyeballing earlier. That when it's grabbing from target, it's grabbing I plus target size and appending it to the label. So that's how it's doing the offset. It's saying, let me append the value 72 later as the next label.
Right.
So that's
instead of just the next one.
Exactly. Instead of target.
And maybe the next measurement would be too easy of a task.
Yeah, and I bet the other one had target I plus 1 since it was just looking at the one next.
Right.
One. So they've really generalized this function for us, which I appreciate greatly.
Yeah, TensorFlow docs are great. Lots of good tutorials there. That probably won't work.
Yeah.
That one will. I'm not the next one might require eager execution.
Yeah, it looks like it could. All the TF data stuff.
Yeah. Let's see what
Oh, it
happens.
looks like it ran, but don't
Okay.
sell the cake shop yet. It may not be. We'll see how it goes
Oh, I think it's
when we
yeah, we'll
actually
see.
use
Maybe
it
we
for
can get,
real. Like we just set up the data sets, but can we actually do something with it? Nope. Right. This is where it actually grabs that from this variable.
yeah,
Yeah.
okay.
Again, same
So that
thing.
won't work since
So
we
if
didn't
you
run
want,
that. We could have run the v1 compat function at the top of the notebook,
mm-hmm.
but
Yeah. So folks at
um,
home watching this in the future should run tf-eager, turn on tf-eager before you proceed at the beginning.
we can put it in the
Yeah.
notes.
Oh, right. And therefore nothing else above it is. Actually, where was epochs not defined? We ran all these cells.
Oh, okay. I think it was in the cell
We
that
skipped.
you train the other model. I guess we did have to run that. Let's just run the variable definition part of that. Where, oh wait, where did we go with that? Back to step. There it
You see
is.
it? Did I
Um,
miss it?
I think it was down a little bit.
So it was after the plots. We did the baseline,
I
and then
think,
we went to RNN.
yeah, I think it was right before training them. There. Oh, I see batch. Never mind. I saw batch size and
Yeah, because
buffer
then we started
size.
talking about RNN stuff. Um,
Maybe just control F for
yeah.
epochs.
Oh, there it is. So it's
Oh,
10.
okay, so we can just comment out the yeah, we could just hard code 10 in
Yeah,
there.
I ran
Probably
it.
easiest.
Yeah,
Oh, you
I
ran it.
commented it
Okay.
out like you suggested. And where are we now? We're back to here.
Okay, so now we're training our model on 3 features, 5 days of data to predict 12 hours in the future.
And I'm really appreciating that
Um,
we're running this in in Colab or just in the cloud in general, just to reduce the load on my
yeah,
CPU here as we're I've got Hangouts open, I'm live streaming, a lot of stuff running, so
yeah,
no complaints here.
lots of bandwidth
Don't
being
mind not
used.
having to run a Jupyter server at the same time.
Um, yeah, so hopefully this won't take too long to
Yeah.
train. We're just going to train for 10 epochs. If you want, while it's training, I can start to talk about like what we'll be doing
Yeah, that might
next.
be helpful. Yeah. And if there's any like general explainability concepts you wanted to cover or talk about, or if folks have questions about that, this would be a good time to throw them in the chat, and we'll catch them there.
Yeah, so essentially, explanations is available on AI platform for TensorFlow models, and that's what we're going to use. It also works on AutoML tables. So if you want to train a tabular data set on AutoML tables, you get explainability by default once your model is trained. We're using the AI platform version. So in order to use that, if you've used AI platform before, you would deploy a model pretty much the same as you would normally without explanations. You just need to export the saved model assets, which is the next step after
Ah,
this.
okay.
Um, so then you would copy those to a cloud storage bucket. Um, and then inside that cloud storage bucket, we're also going to be adding a metadata
Oh,
file where we put some data about our explainable
okay.
model
Huh. I
and
didn't know we had to do
what
that.
to explain.
So would this
Yes.
also then be
Currently,
a good
that's
time? I'll start spinning up the GCP project here that we're going to use. Get that loaded up.
yeah, good idea.
Yeah, on
We
that
can
topic.
look at some stuff in the console.
So hamburger menu, AI platform. Oh, I guess I shouldn't cheat and use the pinned value. AI platform is all the way at the bottom and then up a little bit more. And then there's AI platform. And we are
There
looking
we go.
for models.
Yes.
And here we are. You'll see all the other ones are listed here, and for now we'll clear them out of the way, but if you want to bring them back, you can click that little button on the bottom left. All right, make that bigger.
Yeah, I guess you could actually create a model here in the
Yeah,
UI
get us
while we're
started,
at it.
right? Um,
Yeah.
we'll call it.
So model resource is where you put all your versions. So a model can have many versions I think
Oh,
hundreds
apparently my model
of an
cannot
underscore.
have dashes. Dashes are not welcome here.
Nope, no dashes here.
All right. Any votes on region? Is there any significance here? Do we need data stored somewhere so that it can be more co-located?
I don't think so. Let's do US Central
Okay.
1 that's usually the
It is.
default. Let's enable logging. Why not? It might help us in the future.
The time series model. What's Sarah?
Good description. And we'll create. That should create pretty fast. Model is just kind of like, an umbrella resource where we'll then deploy versions.
There it is.
Cool. So it'll say we've got no versions yet.
I'll click into that.
We will be creating one soon.
How's this working away here? We're almost done epoch number 8.
8 of 10.
Through it.
So yeah, once we have this, we'll be able to...
We'll be able to upload to create a new version. Yeah?
Yeah.
See, that's one of the interesting things about the way we create versions is you have to have your trained model file up on cloud storage, right? Like I really wish, because I assume that it gets copied out anyway, that the AI platform will take your cloud storage trained model file and copy it somewhere else in the back end of the service. So I really wish they would let us upload from local, because it's going to be local anyway. It's not like I can point to Colab and say, grab it from this Colab notebook.
Yeah, I didn't think of that. That would be a useful feature.
Just because not everyone's always familiar
we're actually
with that
gonna.
sort of stuff.
So now that you bring this up, I don't think you can create explainable versions in the UI.
Oh, no.
So we're gonna use G-Cloud. I know.
It's all good. Let me boot up the Cloud Shell then.
Oh. Yeah, I guess we can do it with Cloud Shell.
How are you going to do it? You said you wanted to do it with command line,
I was just going to do it in... I was going to do it in Colab,
oh, yeah, that works.
Cloud Shell works too.
We can do it in Colab. That'll be a more traceable way to do it.
Let's see how we're doing here.
Almost there.
Close.
So
okay.
Close.
So close. So in the interest of time, I mean, we could run the plot train history to see how it did.
That won't take long, right?
We may want, that should be very fast, but we may want to skip to, let's see how it did.
So this was single step training and validation loss. It's hard to tell, like, if it's doing that.
It's hard to tell how validation loss did.
Yeah, because like it went from 0.26, wandered around it a little, and then ended up at like 0.24. Like that doesn't seem like a huge improvement, all things considered.
No.
Well, let's see how it goes, I guess. We've been hit by the eager mode bug again.
I think we can stop here for the notebook cells, and then so for our next step, we'll want to open up the sample notebook on GitHub for deploying explainable models, which I think you've already got loaded up.
Oh, because the trained model is done. We don't need to do anything more with that?
Yeah, we got the trained model assets, so we can just skip ahead to the deployment.
Should I open this in Colab then?
So, no, you could probably just
we just need to look at it.
Yeah.
Fun. Okay.
Yeah, we just need to look at it. We're just going to add on to that notebook. So you'll want to skip to the exporting step.
Okay. Create a storage bucket, downloading, pre-processing data, train, build, evaluate, create a pipeline, export the model. So yes, this was the big note. You must convert to estimator. So let me scroll up to, I'll just do it right after our plot here.
And then we'll just replace model with, after the plot should be good. Export time. And we'll want to, Keras model equals, I think it was called single step model. Single step model, yeah. There we go.
I'll put a new line here just for readability for folks. All right, so estimator, model to estimator, we point at the model, we point at a directory, which is somewhere. What is Keras estimator? What is that value? Is that the estimator itself? Okay, it's the estimator object.
That's the estimator, yep. And
But we got to be able to
in order
find
for
it.
the
Where's the
next
directory?
step, it's called
I know,
export.
but what's the
Let's
path?
see. Yeah, that's a good question. I don't know how the collab uh, image is structured.
Is it in user? Oh man, we might
Maybe
have nerfed ourselves.
it should still work though with the
Oh, we
next
don't
step.
need to actually know the path.
We don't need to
All
know
right,
where it
all right, all
is.
right.
Yeah.
We'll stick to the plan.
Um, in order for the next step to
Mm-hmm.
work, I think you'll have to run that authorization bit.
This piece? For
So
serving functions?
no, the like
Oh,
to,
but in order to do anything with serving
um
functions.
yeah, you could put serving function up
Yeah.
next.
You want to say a blurb about this while I find the authorization code?
Yeah, so what the serving function does is it tells Cloud AI Platform, which we're using for serving our model, what format it should expect from the inputs from the client. And this is the key here is gonna be related to the name of the tensors in our model graph, which is a bit of a tricky concept. There's some utilities we can use to figure it out. So Yufeng's gonna run this cell to authenticate to his cloud account so that we can do some copying of files to our cloud bucket in his project and use that model that he just
Yeah, I'm not
created.
sure if
So we'll
displaying
just
all
copy
those
paste.
values on the screen was the smartest idea in the world, but I assume that we've done it well that the secrets weren't leaked.
Yeah, hopefully it's okay. Okay,
Man.
so if you want to real quick run
Sure.
model.summary, this is a nice convenience method that Keras offers. And it lets us see what the name is of our input that our model is expecting. Okay, LSTM_1. So you see dense above there in the serving function?
Yeah, this one.
You want to replace just dense with LSTM
Oh,
underscore
you
one.
still
You
need
still want
input?
underscore it. Yeah,
Oh boy.
a bit of a gotcha
Just a
there.
little. That's good. That is a
Yeah.
huge note. We need to put like red flashing lights in this part of the live stream to draw everyone's attention to like, do this thing. Do it.
If we had explicitly named the
Mm-hmm.
layer, then I think we wouldn't have to do
Oh,
that.
how does it know that this
Not a
was
hundred.
explicit, not explicit? Like, what if we chose to name it LSTM_1?
That's a good question. I'm
Yeah,
not
but
sure what
maybe
would
there's a
happen.
flag that says this was auto-generated versus a
Yeah.
hand-named. That's funny.
So you
Yeah,
can
I'll
run
rerun
that,
that.
and
And I guess at this point this is older, so I should probably put this down here.
oh, I'm so bad about switching the order of my cells. Good call.
Well, just so like it would be really confusing later on, right? Because like, how did you
Yeah.
know it was this value? Well, I ran it later. Wait, what? Okay, so we have this. We
Okay,
have
so now
this.
you can run that export thing from the other notebook.
Yes.
Um,
We need to pick a bucket to put this in. And this brings us
yes.
to my favorite hack of GCP, having multiple tabs open with the console in it. So we have this tab, but I don't want to lose it. So I'm going to open storage in a second tab, which apparently I can't.
I feel like I'm about to learn.
No, I'm pretty sure
Oh,
everybody
yes.
does this on our team.
Oh,
Yeah,
yes. I thought you were going to open it within the same tab, two different windows. Okay, so
how about AI Explanations
you can
US
use,
Central 1?
that sounds great. Did you already, I guess you probably ran some tutorial in the
It
past.
is very possible.
You're ready to go. Okay, so let's just,
That's hilarious.
it will use the explanations directory by
Yeah,
default.
I
I think
yeah.
we'll
And
just
we
in
can
the
use
code.
that same directory. I just wanted to check what was inside. It looks like it's fine. It was a different export from a different era.
Maybe a while back you
So
deployed an
bucket
explainable
name
model.
is that, and I can just run this straight
Yep.
up.
Yeah, that should work.
And will
Fingers crossed.
this actually upload it?
Yeah, so if you refresh
What?
that bucket when this completes, isn't that cool? You can put a cloud storage
That
URL.
is a nice update. I have not done that before. I've only ever exported to a local path and then literally would have to download it from the Colab notebook to my local machine, upload it to cloud storage manually, and then point to it, which was just the worst workflow. So
Yeah, it supports cloud storage
very
URLs,
pleased.
which is pretty cool. So now we have our new one, which I think
It's this
is
one,
probably that one.
created April 1st.
Yep, April 1st. There we go. So we are close. We are not yet ready to deploy yet. The tricky part is coming up. We need
Oh,
to
you mean the stuff we just did
create.
wasn't the tricky part?
No. So we need to create a metadata file to tell the explanation service what tensors we want to explain. So that line of code, the save model CLI, will help with that.
Let's run it then. Anything to help the cause.
So exactly.
All right.
This is a utility.
I've played around with it a little bit before, but never really knew what it was meant for.
Yeah, so this shows you the names of the tensors for your model, the input and output tensors.
Handy. Very handy.
The serving default key in the signature def is what AI platform will use when you deploy your model. Which
this one.
Yeah, that's the only one we have here. Sometimes you'll see a lot of different keys.
Yeah, there's just a lot of words that are concatenated together, so it was like hard to just like see what I was looking for even.
Yeah, it's a little confusing. So we want to take note of the name of the input tensor.
Which we set.
And the shape of it.
Right, we chose that
value. So the name is actually.
Don't tell me it's not that.
It's not.
It's
that.
this.
It's no. This. See under inputs. See where it says D type shape name.
D type shape name.
That's the name.
With or without the colon 0?
With the colon 0.
And how do I know it's this one and not this one?
So that's the output tensor.
Yes.
So you will need both.
Okay. But this is the
row
input
I'm looking is for. The format. Yeah, so if you go back to the other notebook, the GitHub one, you should see, we can just copy that metadata in there. You can skip the printing.
I actually was curious what it would say for our particular model. Is it the names that we were trying?
Yeah, so sometimes it doesn't.
The names I was looking for are indeed.
Sometimes, so the confusing part is it looks, for our case, they're the same.
Sometimes it's different.
They're not always.
They're not always the same, but like, which one do we really want? Like if they were different, which one would we choose?
We want the one from the serving default in the signature def.
Okay.
So the output, we want the output of save model CLI.
Not the output of this.
Right. In some models, what I've normally seen is that the output is different. Input tensor is usually the same. Okay, so we need to update our metadata a little bit to
match our stuff.
Reflect. It looks like model.input.name looks correct.
And we could hard code it if we wanted to, or if it were different, right? We could put this right here.
Yeah, we could do that.
Just to be explicit.
Just to be safe. Same with output. Let's just do that.
Grab that.
Output.
Put that in here.
You can delete the encoding and the feature mapping keys. So what that's for is a typical tabular model will have, a few named features. So if you're passing your inputs to your model as a NumPy array instead of a key value pair, this is a handy little utility where you can map each of the
columns,
inputs in your NumPy array to feature names so that when you get your response back, it'll say, okay, for this feature, age, this is the attribution value. So you don't have to do that mapping yourself. Right. In this case, we don't really have named features. It's just a window.
So I'll delete this.
Yeah, you can delete that. Then we're going to look at the concept of baselines, which we're going to need to update that a little bit. So what the baseline value is essentially is like when you explain something, you're explaining an event, like why did this thing happen? The baseline is what you're comparing that against. So why did this thing happen compared to some other thing?
We saw some of that with the np.mean.
Yeah, exactly.
Great.
So I think we're gonna use the median here just to keep things simple. So let me remember what our training
Oh,
data
we just need to change this
was.
variable, basically.
Yeah, and I think we're dealing with a NumPy array, so we'll just do np dot median and then pass it whatever the name
Yeah,
is
do you
of.
remember the name of the variable? Also, which data set are we looking at off of?
I think it's x train single. So x underscore train underscore single.
All right. I will take your word for it in the interest of time and sanity.
Let's hope for the
X
best.
train. Oh, look at that. Autocomplete for the win.
Yeah, Colab is
All right.
great about
So when you
that. So
NP
instead of,
median like this,
I think
and we
so,
won't
yep.
need
And then you can just
values
get rid of the,
either.
or
Oh, we
two
won't need that either.
lists.
Great. Do we still have to wrap it in the list though? Like,
We
okay.
do,
It's a list
yeah.
of lists.
So the service will automatically expand this to the size of your input
Great.
array. So I think
All
we're
right,
good
let's
there.
run this, set this explanation metadata value. Looks like the next thing I need to do.
And then
Oh, we got to write it out.
next will
Reasonable.
be, yeah, we'll write it to a local file.
Reasonable.
And then we will copy it to our cloud storage bucket where our model's deployed. Oh, we have to import JSON.
Good stuff, good stuff. And we're going to copy this out. With any luck, this export path will have a value in it. I'll check what this is after.
I think we set it before to
I
our
just hope it's
cloud
what we
storage
thought
bucket.
it was.
Yeah. Oh, do you want to just refresh your bucket to make sure?
Yeah, this got put up here, but
over.
let's see what is in here.
It should be in the.
Oh, is that the top level?
Yeah, that's the top level. It should be. I think it's the. No, if you go to explanations, click the bucket. Yep.
Oh, you drill in. Oh yeah. Okay.
Yeah, to the. I think it was the second one. There we go. Cool. Okay, so now I think we're ready to deploy the version.
Yeah, we have our.
Let's double check.
We have our model up there. We have our metadata up there. This guide seems to believe that we can create the model at this point.
Yeah, I created the guide, so let's hope it's correct.
Well said. All right, so I'm going to copy this, and I'm going to. This is probably my biggest pet peeve about AI platform. You'll see in a second. What do we call this?
Oh, we can't do it from the UI. Remember?
Good times.
So you copy the
this.
gcloud command.
See, we need the model. We need the bike. I'll just.
We actually don't need that.
Oh, we already created the model.
We created our model
but we still
already.
need the model variable for later, since we'll have to.
We need the model variable, yep.
What did I call that model? Trivia question.
I can't remember.
Who remembers?
Adventures, Sarah.
All right.
There we go.
And we're going to grab this whole thing. I'm going to call the version something.
Okay, and yeah, we can call it v1. We're going to have to change two things in this command because we're going to be using a different explanation method. So there's a few explanation methods available. I'll talk about them after we.
It's sample Chapley. Did I spell it right?
Sample Chapley, and then you'll want to change that last parameter. You did spell it right. To num paths instead of num integral steps. And let's just make it 10. Yeah, perfect. We'll make it 10. This might make it. Okay, and that should kick off our deploy.
Okay, I will try to run it.
Let's see what happens. Fingers crossed.
Error.
Let's see.
Project is not set.
Oh, right. Got to run the gcloud config set project.
Yeah, I saw that at the top of this. And I was like, ooh, we're going to need to do that sometime.
Yeah.
Oh, okay. So it's this guy. Yeah?
Yep.
Okay, I can just run that directly without the environment variable.
I think it's your Cloud ML demo, right? Project.
My favorite. Do I need quotes, you think? Probably not.
I don't think so. Let's find out. There we go. And
explanations reflect patterns in your model, but don't necessarily reveal fundamental relationships about your data population. See this link for more information.
That's actually good. That's a good disclaimer because, explanations are only as good as the data you use to train your model and, your model itself. So that's actually an important point because, when you train a model and evaluate it without explanations, you're probably looking at accuracy, maybe some other
Mm-hmm.
metric. Um, and you might say, how can we trust accuracy? Well, explanations kind of goes one level
Right.
deeper. And you don't want to take, you don't want to just entirely default to trusting your explanations. You want to make sure that they're based on, a good training data set,
So what you're saying is
model,
that all
etc.
of those models that are claiming to have 100% detection accuracy and just ship it and saying that they can find all the COVID-19 patients with 100% accuracy and only 10 data points. Not entirely valid.
Exactly. Right.
Yeah.
You got to look at, the data, underlying data that you use to train your
What
model.
kind of time period should we expect this to deploy to take? It looks like it's giving me a text box. Am I supposed to say something?
No, that's something that Colab
All right. Well,
does.
I'm going to say something
Um,
anyway.
let's see what
Yes.
happens. I should mention also you could run this in AI platform
Uh-huh.
notebooks.
Which
Another
is
alternative.
over here. We'll do something
Yeah,
with
and
that
you
on the live stream at
you
some
could
point.
then skip that authentication step
Ah, yes, that's right.
since
And the project will also be set.
yeah, you don't need to run the config set project either. You're right. Oh, if you refresh this
Yeah, I
page,
was gonna
you should
back
see
up
the
and
version.
it should
Let's
at least
see.
be in progress. Woo!
Yeah, there we go. You can click on it too. It should
Something
say that it's deploying with explanations.
nice. Proof. Where does it say it?
All right. So, um, okay, it doesn't. There's a version describe command you can run in Gcloud too, but we don't have to do that now. I guess
There's
we can
this
just wait.
evaluation thing. Is
Uh,
that part of? Oh, that's a separate thing.
that's something else. Actually, you know what you could do is you could cancel that cell running because it's already
Uh huh.
deploying. Um, and in the interest of time, we could start to set up some input data to send our model.
Yeah.
Let's do that. So if you go back to the other notebook,
This notebook.
the
This notebook.
GitHub one, yeah. Let's see what's next after the deploy step there.
We're gonna get predictions. We need to set up our request.
Yes. Oh, you could run that. So that cell above is describe.
Oh,
You could run that now.
nice.
And that should say creating.
Yep.
Creating. And there's the explanation config thing.
Oh yeah. Nice.
I thought we would see that in the
Yeah.
UI, but I guess not. Okay, so next step is making predictions. So we're gonna I think what that notebook does is we create a JSON
Mm-hmm.
file and we'll send it with Gcloud.
Okay.
So we'll just need to make
We need to grab the data from our time series data set now.
yeah, you can copy that cell where we're creating the file from the other notebook and we'll just make some modifications to it.
Yep.
Okay.
Well, we don't have to.
So let's just call it data.text. And then remember it's LSTM_1_ input.
Oh, is the
Is the key. Not the most intuitive, perhaps. And then
we need the test.
I think test data, I think, is xval single again. And I don't think we want iloc
because it's not a pandas array.
Because it's not a data frame.
Yeah. Should we delete this whole thing?
So I think you want 0 still, and you want 2 lists. Let's see. You can print that out and see if that looks right. I don't think we need values because it's not pandas anymore.
Yeah, it's already a NumPy array. Yeah.
So we should be good without values.
Nice.
There we go.
I'm gonna clear this out. Well, I can. How do I? Oh, there we go.
Oh, I didn't know you could do that. Cool.
Yeah.
Okay.
So we can just dump this out as a data.text.
Yeah, and then it looks, so we're just going to send the first value to our deployed model. Why don't you just cat data.text and see if it looks reasonable?
So it's a curly LSTM input, bracket, bracket, and then a big list of numbers, and then it closes it out.
Cool. Yeah, so each array in there is 3 elements because we have 3 features for each day. Or not day, but whatever time step we're using. I forgot what it was.
Okay, yeah, it's 120 by 3. So it's 120 rows with 3 columns each. So it's these 3, then these 3.
Yes, 120 observations. Yeah, so next if you want to copy in the next 2 gcloud commands,
so we're going to,
those should make...
Yeah, we make the request and get the response.
Yeah.
And we have everything. Oh, change this file name.
Yeah, let's run that describe cell again just to see if it completed.
Yeah, the UI seems to think it hasn't yet, which is unfortunate. It's still creating.
I know. Oh, man. Okay. Well, we could also set up our visualization cell to run. I can't remember if that's in there.
Yeah, there's a bunch of code here about...
No visualizations here, I don't think. So I might have to just walk you through this part. I don't think I can copy paste in the notebook, can I?
I could try sharing it to you.
Oh, let's see if that works.
Okay. So I'm going to switch to just us while I do this so we don't give away your email addresses. All right.
Okay.
And
I got it.
Yeah.
Cool. I'll just add it in as a comment so that I don't mess up any.
I think you can just make a new cell and paste it in. I think it's done deploying, by the way. The UI was just stuck.
Oh, cool.
Yeah.
Okay, in that case.
We can check with that command again, but it looks like it finished. Yeah, it's ready now. I'll try running this command while you get that pasted.
Yeah. Let me just scroll down to where we are.
It ran, and we have a response. And what do we do with this?
Do you want to just print response to make sure it works?
Yeah.
While I do this. Hold on one sec. I'm just gonna paste it there.
Where are you on the notebook?
I'm in the cell before. Well, let's see what response shows. Oh, cool. Looks like we have attribution values. So this attributions array is the same shape as our data input. So each feature is going to get an attribution value. I think you may want response of explanation. Oh.
That's all good. I just wanted to see a list of the names of things that come in.
Yeah, that would be useful. I copied this into the cell above multi-step model. Header.
Multi-step model. Let's use our shortcuts. Multi-step model. Where is you?
I didn't want to interfere with what you were doing. So multi-step model. There we go.
Multivariate time series.
Down a little bit.
Oh, down here.
Keep going. Multi-step model. Yeah.
Great. Get rid of this. Plotting this? Multi-step plot. Oh, all of this.
No. Oh, I guess it didn't show up.
It says the file was updated remotely or in another tab. It must not support simultaneous editing the way it used to anymore.
Yeah.
So we might have to skip out on plotting today.
Yeah, I can. Oh, I could. I guess I could. Could I add it as a YouTube comment?
Yeah, the code. That'd be funny.
Should I just do that?
Yeah, you could. Yeah, you could throw it in the chat or something.
Okay. Unless we should just stop and debrief since we're we're kind of out
Yeah,
of
we are
time.
running out of time for folks. I don't know if people are willing to stick around to watch us debug, though I guess that's the true live stream experience.
Yeah. Let me just
Okay.
paste it. I just pasted it in the chat,
Okay, yeah, it's
the
not
YouTube
long.
chat.
And this is, we can just get it formatted and stuff. So,
Yeah. We should make sure that I think all the variables are right. We
okay,
might need
so
to
it's
change a
one
few for
line
this
right
data
now
set.
because
Oh yeah.
YouTube,
So after the for
yeah,
statement, we'll break it up.
for blah blah blah
And
and blah blah
then
blah. Python. Oh, it's just this. Oh, is this? Are they both in the for loop or one in the for loop?
the PD's in the for loop
Wow.
too. PD.dataframe.
Okay, so we're gonna have
Let's see if
just
that
run it. You know, who
runs.
needs a
Just run
invalid
it.
character in identifier? What does that even mean? Do,
Oh, did something weird happen in the copy paste?
I mean, look at the.
Maybe? Was there an extra
Yeah,
space?
that's what I'm trying to figure out. It's invalid. What?
That's super weird because it looks the same as what I have in my notebook.
What if I for ival?
You could try Control Shift V. I wonder
Oh,
if the
I
quotes
retyped
are
it. It
wrong.
worked.
Ah,
I don't know
cool.
why.
Okay, yay! We got
Oh, yeah.
attributions, and we're plotting them.
Nice.
So what this is showing us, essentially, like the high level summary I would take
Mm-hmm.
away from this is that more recent time steps are most important to our model in making a
Right.
prediction.
And pressure,
Um,
pressure, the blue line is especially useless regardless of when it's from.
yeah, exactly. But it looks like temperature and what we said was air
Mm-hmm.
density, I think,
We think. Rho.
um, are useful. And it looks like the most recent time step isn't actually the most useful. A couple measurements before
Yeah,
that.
that's surprising,
Um,
but very cool.
and so positive values here indicate that this particular feature pushed our model's prediction
Mm-hmm.
up. Negative, so the below zero ones that you see a little before
Uh-huh.
that means that pushed the prediction down.
Down in
So
value or like
again,
made it worse?
down
Oh,
in
okay.
value. Yeah, especially so we have a regression model here. We're just predicting, a single scalar
Right.
value in the future. So a negative attribution value means that particular feature pushed the model's predicted temperature, I guess, in this case,
Uh-huh.
down. So an interesting next step would be to see, okay, what if we trained only on like time steps 80 to
Yeah.
120? Would the graph look
Yeah, because that's where all the interesting stuff is
just
happening.
the same? Yeah, I'd be curious what the graph would look like
Yeah.
then.
Maybe I can convince you to come back on for another hour in a little bit, sometimes on a future date, and we can play around with that. That'll be interesting. Do it live.
Yeah, definitely. I'm glad we got something
Yeah,
deployed within the
yeah.
hour,
Even if it only just barely.
just barely, and we got it
Yes,
visualized.
yes. Thanks to your YouTube comment pasting skills, most excellent.
Yes. Cool. Well, thanks for having
Yeah,
me on
this
the
was super
show.
fun. Thanks for coming on and sharing this with me and everybody else. And yeah, I guess with COVID and social distancing, I guess I don't know when we'll get to see each other in person again, but I hope you'll come back on and we can mess around with AI explanations again sometime in the future.
Yeah, part two. And if anybody has thoughts on explanations, especially for time series models, I'm interested to hear what people think, how to interpret explanations for those types of models. You can find me on
Yeah,
Twitter. We'll post the details here. I'm SRob
yeah.
Tweets.
Hit up Sarah at SRob Tweets. And with that, we'll close it out for today. Thanks for joining us, and we'll see you soon.